Hello. And welcome back to the Umbrella Academy.
In this lecture, we will discuss IUPAC nomenclature of alkanes. IUPAC means International Union of Pure and Applied Chemistry. This international committee has framed systematic rules for naming organic compounds. Time to time, some changes were suggested. At the end of this lecture, we will see what changes have been made in 2013 regarding naming of alkanes. According to IUPAC, the name of an organic compound contains a root word. Root word denotes the number of carbons in parent or longest chain. This is followed by primary suffix or suffixes. This denotes whether the compound is saturated or unsaturated. That means whether the molecule has only single bonds between carbons, or any double or triple bond exists anywhere in the carbon chain. The primary suffix may in turn be followed by secondary suffix, which indicates the functional group with highest priority present in the molecule. The root word may have a prefix or prefixes prior to it. The prefix indicates the substituent or functional groups with lower priority. In between root word and prefix, sometimes the name has infix, which indicates whether the parent chain is cyclic or spiro in nature. And these substituents are written in alphabetical order. Now let us see the root word for particular number of carbons in the parent chain. Let me write the parent chain carbon numbers in this column. For 1 carbon, root word is meth. For 2, eth. For 3, prop. For 4, but. For 5, pent. For 6 carbons, root word is hex. For 7, hept. For 8, oct. For 9, non. For 10, dec. Now, let us see what primary suffixes we use for saturation and unsaturation if the parent carbon chain contains only single bonds. Then we use suffix ane with root word. If double bond is present in the parent carbon chain, we use suffix ene with root word. And if there is a triple bond between carbons in parent chain, then we use suffix yen with root word. For example, take this molecule, CH4. Only 1 carbon is there, so root word is meth. There is no chance of double or triple bond because only 1 carbon is there. So the primary suffix is an joining the 2 words. The name becomes methane. Now take this molecule. 2 carbons are there, so the root word is eth. 2 carbons are single bonded, so the suffix to be used is ane joining the 2. The name becomes ethane. Likewise, in this molecule, 3 carbon are single bonded, so root word is prop and suffix is ane. The name becomes propane. For this molecule, the parent chain has 4 carbons which are single bonded, so root word is but and suffix is ane. The name becomes butane. Now consider this molecule. It is branched. As per IUPAC rules, we have to choose the longest possible carbon chain and number the carbons, so that the branch point gets lowest possible number. So we number this carbon as 1, 2, and 3. This is the only way the longest chain of 3 carbons can be numbered so that the branch point gets number 2. The carbon 2 has branched carbon with 3 hydrogens. It is called alkyl group. Alkyl groups are formed by removing 1 hydrogen. To name these alkyl groups, we replace the suffix ane of the corresponding alkane by the new suffix yl. Thus, if we take methane, CH4, and remove 1 hydrogen, so that it remains CH3, it is called methyl. Ethane after removal of 1 hydrogen becomes ethyl, and propane after removal of 1 hydrogen becomes propyl. Now coming back to our example. The root word for 3 carbons is prop, and the suffix for single bonds is ane. The branch point here has 1 carbon, so it is called methyl. To show the location of the substituent, we write the number in front of the name of substituent. Thus the name becomes 2-methylpropane. There is no space between the prefix, root word, and suffix. Let us go a step further. Consider this molecule. The longest possible chain is of 5 carbons. If we do the numbering from right side, the branch point gets number 4. As per IUPAC, the numbering is to be done in such a way so that the branch point gets lowest possible number. Thus, this numbering is incorrect, because if we do the numbering from left side, the branch point gets number 2, which is preferred compared to 4. The parent chain consists of 5 carbons, means root word is pent. Only single bonds between carbons mean that suffix is an. The branch point has substituent methyl at carbon number 2, thus the name becomes 2-methylpentane. Consider this molecule. Now there are 2 branch points. If we start numbering from right side, the branch points get number 2 and 4. And if we do the numbering from left side, the branch points get the same numbers 2 and 4. In such situations, you should not be confused about which way to start the numbering, because both are correct. There is no distinction. Now for 5-carbon parent chain, root word is pent. There is no double or triple bond between carbons in chain, so suffix an is used.
Now both the substituents are methyl. We mention the location of substituent, that is, 2 and 4. And we write D for 2 methyls. These numbers are separated by commas. Thus, combining prefix, root word and suffix, the name is 2,4-dimethylpentane. Now take the same molecule and change one of the methyl substituent into ethyl group. This straight carbon chain has 5 carbons. But if we move like this, we can see there are 6 carbons in the chain. So longest chain has 6 carbons and not 5. This is why you have to be careful while choosing the longest possible carbon chain. Now, with this numbering we have methyls at C2 and C4. If we try the numbering from right side, we have methyls at C3 and C5. Sum of locants 2 plus 4 becomes 6. And 3 plus 5 becomes 8. The lowest locant sum is chosen. Thus, numbering from left side is correct. Now for 6-carbon parent chain, root word is hex. Suffix will be ane. The prefix for substituents is methyl, and we mention the location 2 and 4 and write D because methyl substituents are present at both carbons. Thus combining, we get the IUPAC name as 2,4-dimethylhexane. Now take this molecule which has 2 different alkyl groups, methyl and ethyl. Do the numbering from right side. At C3, we have ethyl group, and at C7, we have methyl group. Now try numbering from left side. At C2 we have methyl group, and at C6 we have ethyl group. Here the sum of locants is 10 and here it is 8. Thus this is not opted. And this is the correct way. For 8-carbon parent chain, root word is oct. Suffix is ane, because all carbons are only single bonded. Now we have methyl group at C2 and ethyl group at C6. Here is an important point. When writing the prefixes for substituents, we write in alphabetical order. Here ethyl will beat the methyl in alphabetical order. So we write 6-ethyl-2-methyloctane. Before proceeding further, let us first discuss the names given to branched alkyl groups. First, we will take 3-carbon branched alkyl groups. Consider this 3-carbon compound. It is called propane. Based on degree of substitution, these terminal carbons are primary carbons. And this central carbon is secondary carbons. Likewise, the hydrogens attached to primary carbon are designated as primary hydrogens. And those attached to secondary carbon are called secondary hydrogens. If we remove the primary hydrogen and attach this group as a branch, through this bond to the parent chain, we call this as propyl group. It can be simply written like this. If we remove the secondary hydrogen and then attach this group as a branch through this bond to the parent chain. We call this as isopropyl group. It can be simply shown like this. Now take 4 carbon branched alkyl groups. Consider this molecule. It is called butane. Based on degree of substitution, these are primary carbons. And these are secondary carbons. The hydrogens are also designated based on to which carbon they are attached. If we remove the primary hydrogen and attach this group as a branch through this bond to the parent chain, we call this as butyl group. It can be simply shown like this. If we remove the secondary hydrogen and attach this group as a branch through this bond to the parent chain, we call this as secondary butyl group. Secondary is abbreviated as SEC. It can be simply shown like this. Consider this molecule. It is called isobutane. These are primary carbons and this one is tertiary carbon. If we attach it to parent chain as a branch from this primary carbon, we call it isobutyl. It is simply represented like this. If we attach it to parent chain as a branch from this tertiary carbon, we call it tert-butyl. Tert means tertiary. It is simply represented like this. Now an important point to remember here is that none of the prefixes such as D for 2, tri for 3, tetra for 4, SEC for secondary, tert for tertiary, are considered for alphabetical order except the ISO, which is considered for alphabetical priority, whenever present. Consider this molecule. Let us do the numbering from left side. We have 1, 2, 3, 4, 5, 6. If we move upwards, we have this as 7 and 8. If we move straight, we have 7, 8, 9. Thus longest chain is of 9 carbons. At C3 we have ethyl group. At C6 we have tert-butyl. If we do the numbering from right side, this carbon gets number 4 and this gets 7. So that, at C4 we have tert-butyl and, at C7 we have ethyl. The numbering that gives lowest locant sum is opted. For 9-carbon parent chain, root word is non. Only carbon-carbon single bonds are there, so the suffix to be used is ane. For alphabetical priority of prefixes, the prefix tert is not considered for alphabetical order. So butyl beats ethyl in alphabetical order. We write 6 tert-butyl 3 ethylnonane. Consider a similar molecule with 9-carbon longest chain. At C3 we have ethyl. At C6 we have isopropyl. The root word is non. And suffix is ane. Now prefix ISO is considered for alphabetical priority. So ethyl beats ISO in alphabetical order. So we write 3-ethyl-6-isopropyl nonane. Now consider the same molecule with additional substituent bromine here. In case of halogens as substituents, the prefixes are, for fluorine we write fluoro. For chlorine we write chloro. For bromine we write bromo. For iodine we write iodo. Now with numbering from left side, at C3 we have ethyl. At C6 we have isopropyl. At C7 we have bromo. If we do numbering from right side, then at C3 we have bromo. At C4 we have isopropyl. At C7 we have ethyl. Sum of locants for this is 16. And here the sum of locants becomes 14. This is wrong and this right side numbering is chosen. Now the root word for 9-carbon parent chain is non. The suffix is ane. As per alphabetical order we write 3-bromo-7-ethyl 4-isopropyl nonane. Now we will see what recommendations have been made in IUPAC 2013 meeting regarding the nomenclature of alkanes. Consider this molecule. The blue chain is the parent carbon chain. and substituents have been shown in red color. Take this one first. The common name for this group is isobutyl. As per new recommendations, the carbon chain is numbered with number 1 starting from the carbon attached to the parent chain. The suffix for substituent branch chain is YL. At C2 we have methyl group. So we write 2-methylpropyl. Take this one. The common name for this group is neopentyl. As per 2013 recommendations, we have to do numbering starting from this carbon connected to parent chain. So the numbering is 1, 2, 3. At C2 we have 2 methyl groups. So we write 2,2-dimethylpropyl. In this case, the common name is SEC-butyl. Using the same rules as before, we number carbons like this. So we write 1-methylpropyl. For this group, the common name is phenethyl. As per new rules, it is called 2-phenylethyl. For this group, the common name is benzhydryl. As per new rules, there is only 1 carbon attached to 2 phenyl rings. So we call it diphenylmethyl. As per 2013 IUPAC Blue Book, this group is still called isopropyl. And this group is still called tert-butyl. There is no change in naming these 2 substituents. Here are few examples of alkane nomenclature. But here, 2013 IUPAC recommendations are not taken into consideration while naming the substituents.
If you don't want to miss out important lectures, then subscribe and press bell icon for notifications of new lecture uploads.